video is going to be the first of two for 2-6 quadratic formula. And the first thing I want to go through is this proof. This is actually the beginning activity for 2-6, which you were assigned in savasrealize.com. I can't remember if it's explore and reasoning or critique and explain, but this is basically what it's asking you to do. So we have this standard form quadratic. A, B, and C are letters, but again, they do represent numbers. And we want to solve using completing the square. So to do completing the square, I am going to move the C to the opposite side, and I have to divide everything by A. So I'm going to do those all in one step. So we went through, divided everything by A, and then I moved that C term over. Now in completing the square, we take our B term, which is B over A, and rather than writing the B over 2 squared, I'm actually just going to make that B over A. I'm sorry, B over A over 2. Let's do the whole thing there. Okay, so B over A over 2. We're going to square that. Anytime you have a fraction and you are dividing it by something, you're really multiplying those denominators together. So this is the same thing as B over 2A squared, which is B squared over 4A. So that's what we're plugging in. That's what we're going to be adding to both sides here. So we have x squared plus B over AX plus B squared over 4A. Sorry, forgot the square there with that. And that's equal to negative C over A plus B squared over 4A squared. So on the left-hand side, we are going to factor this. This is going to factor into x plus b over 2a, and that quantity is squared. On the right-hand side, we actually have to go through and combine these two fractions together. So your common denominator between these is going to be 4a squared. I already have a 4a squared with my second fraction. To make the first fraction have 4a squared, I need to multiply the bottom by 4a and the top by 4a. And so whenever I combine those, and I'm going to do that up here, I'm going to have a negative 4ac plus b squared all over 4a squared. Now, typically on the top, and you'll see once we actually get to our final answer here, typically we do rewrite this as the b squared minus 4ac. So the b squared is actually going to go first there. So b squared minus 4ac. Now, using the completing the square process, we would take the square root of both sides. So you have x plus b over 2a is equal to, remember when we use that square root property, we have to do the plus or minus. With the fraction, whenever you take a square root, you take the square root of the top and of the bottom. The top is going to stay square root of b squared minus 4ac because I can't take that square root. However, on the bottom, I can take the square root of the 4a squared, and that's going to give me a 2a. So I'm going to scroll here so I have a little bit more space to work. So then I would subtract the b over 2a from both sides. So we have negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Well, both of those fractions have the same denominator. So I can write this as negative b plus or minus the square root of b squared minus 4ac all over 2a, because both of them have the same denominator. We can combine the top, and this is the quadratic formula. So that is the quadratic formula. You may have seen this in a previous class. Typically it's introduced though without doing any of the background of how it actually comes to be. But the reason that the quadratic formula exists is because of completing the square. It's actually a completing the square shortcut. So given your original question, you're going to identify your numbers for A, B, and C, and everywhere that those letters occur, you're going to replace them with the number. And that's our lesson for today. So again, this is 2-6. This is the quadratic formula. You can see here this was explore and reason. This is what you guys actually did in the Savvis Online. So you don't have to worry about going through and doing this again unless you want to actually look at your workbook. That would be page 53 in your companion. So our essential question, how can you use the quadratic formula to solve quadratic equations or to predict the nature of their solutions? The prediction part is going to be part of our second video. For this first video, we're mainly going to focus just on how to use the quadratic formula. So again, here is the quadratic formula. You do have to have your equation set up in standard form, so it does have to be equal to 0. You're going to identify your values for A, B, and C, and then plug them in where appropriate. Okay, so here's example 1. What are the solutions to this equation? We have 3x squared minus 4x minus 9. So the first thing I want to do is identify my A, which is 3, my B, which is negative 4, and my C, which is negative 9. So notice we went through, and if there was a negative with a number, that negative gets carried through with the A, B, and C value. So quadratic formula, if my board will let me write up here at the top. And this is something I suggest you memorize. It'll make your life a lot easier if you can just spout off the quadratic formula instead of having to continually look it up. So x equals negative b, well, b was already a negative, so that's going to become a positive 4, plus or minus the square root of b squared minus 4 times my a times my c. And then that's all over 2 times the a value of 3. So inside the square root, we have 16. And then we have, we multiply these together, 36 and 3. This should be plus 108. So 16 plus 108. And I'm sorry, my brain is failing me right now, so I'm going to go ahead and get a calculator with that because it's been a very long day. You'll find with the quadratic formula, you may get, excuse me, you may get some higher numbers than you would if you were just going through and completing the square. So that's something to consider. You could still go through and do the completing the square process, move the 9 over, divide everything by 3. That one might give you fractions. This one though, I get down to this point, I have x equals 4 plus or minus the square root of 124, the whole thing divided by 6. One thing to remember with square roots is you can only divide square roots by other numbers that are in square roots. So the 6 and the 124, I can't do anything with that right now. However, 124 can be broken down. We can reduce it like we reduced the square roots back when we were starting in section 2-4. So 124, the greatest perfect square factor of 124 is 4, and that's 4 times 31. So this is actually going to turn into 4 plus or minus 2 square root of 31, and then the whole thing all over 6. Again, the square root of 4 becomes the 2, the 31 stays inside the radical. Now, all the numbers on the outside, we can now reduce. We can divide those all by 2. The 31 can't be touched. So your final reduced answer is going to be 2 plus or minus. You can put the 1 if you want, but you don't have to. Square root of 31, and then divided by 3. Now remember, this does give you 2 answers. You have 2 plus the square root of 31 and 2 minus the square root of 31. So just remember that. It's not a single answer, it's actually 2 answers. Okay, here's our next one. How can we use the quadratic formula to solve this equation? So again, we're going to start with identifying our A, B, and C. So again, the formula starts negative b. B is already negative, so it's going to become a positive 9, plus or minus the square root of b squared minus 4 times a times c, and then the whole thing divided by 2 times a. So in this case, inside the square root, we have negative 9 squared. By the way, notice that I did put parentheses around that. Especially if you're using a calculator, you need to put parentheses around the number that you're squaring with the square outside of those parentheses. If I didn't use parentheses there, it would tell me that negative 9 squared is negative 81. That's not what we're looking for. So make sure if you want the square to apply to the negative as well as the number, you need to make sure that you put it in those parentheses. So I have negative 9 squared minus 4 times 1 times 27. And this is going to give us a negative 27. So again, I have a square root I have to break down. I also have a negative, which means I'm going to have an I in my answer. So that square root of negative 27, you're looking at 9 and 3, and then you also have the negative 1. So this is going to become 9 plus or minus 3i square root of 3 all over 2. The outside numbers aren't divisible by 2, so I can't reduce this anymore. That's going to be my final answer for that. And again, that was a lot quicker than it probably would have been to go through the completing the square process. So that's something to keep in mind. Okay, now we have an equation. We're going to solve using 2 different methods and then talk about preferences and which one might be the better fit. So the bigger space, I'm going to use the quadratic formula, and I'll talk about the smaller space here in a moment. So my A, B, and C, my A is 6, B is negative 7, C is negative 20. So again, I have a negative 7, so I'm going to have 7 plus or minus the square root, negative 7 squared minus 4 times 6 times negative 20, and then the whole thing divided by 2 times 6. So inside my square root, I have negative 7 squared minus 4 times 6 times negative 20. So that's 529, and then divided by 12. 529 is a perfect square. The square root of that is, I believe, 23, and it is 23. So this is actually, when you have a perfect square there, the square root is going to disappear, and you have something like this. So this is going to give us 2 different answers. We're going to have x equals 7 plus 23 over 12, and we have x equals 7 minus 23 over 12. Well, 7 plus 23 is going to be 30. 30 over 12, both of those can be divided by 6. So that's going to be 5 halves. So that's one of my answers. The other one, 7 minus 23, is going to be a negative 16. Negative 16 over 12, both of those can be divisible by 4. And so that's going to turn into negative 4/3. So those are your 2 solutions, 5 halves and negative 4/3. And I'm just checking myself because for some reason I'm doubting basic math. Okay, we're good with that. So this was quadratic formula. If we look at factoring to solve this, I'm looking for factors of 6x and the 20. I'm trying to make the 7. Because I'm trying to get to that 7 and I'm going to have 1 plus 1 minus, I'm probably going to be splitting the 6x up into 3x and 2x. So now I'm looking at factors of 20, and again, I want things that are relatively not super close together, but somewhat close together. So I'm probably going to be looking at using the 5 and the 4 for the 20. So if I do a 5 here, 5 and 3 would be 15. 4 here, 2 and 4 would be 8. And when I subtract 15 and 8, I actually get 7. But I'm trying to make a negative 7, so I want that one to be negative and that one to be positive. So negative 15 plus 8, that would give me my negative 7. So then I set each of these equal to 0. So we get 5 halves and negative 4/3, which are the same two answers that we got with quadratic formula, but there was a little more guesswork involved because we had to figure out the proper factorization. So your preference here is really going to depend on your comfort level. If you see that something factors quickly, once we move beyond this section where I do actually want you to practice quadratic formula, you can use whatever method you want to solve. If you see an easy factorization and you want to go ahead and factor it, feel free, go ahead and factor it. If you don't see the factorization quickly, you know that the quadratic formula will always work. So that's just something to keep in mind whenever you're going through and doing these types of questions. So that's going to wrap up our part 1 video. Again, make sure you watch the part 2 video as well so you can see further about how we can actually predict what kind of solutions are going to happen without actually fully going through and doing the quadratic formula.